You've probably seen this exact thing happen 1,000 times before. A strong magnet snaps instantly onto a steel spoon. But try that exact same move on an aluminum soda can, and the magnet completely ignores it, sliding right off. Both of these objects are pure metal. They feel identical in your hand. They both conduct electricity and share the same shiny exterior. Most of us assume that magnets naturally stick to all metals, but the property of magnetism doesn't rely on the broad labels we assign to a material. The reason these two items react so differently is entirely invisible at this scale. Since the surface of the material doesn't provide the answer, the real difference lies deep within the invisible arrangement of its atoms. Shrinking past the surface, we reach the material's building blocks. Inside every atom, orbiting electrons constantly move. Each acts like a microscopic magnet with its own directional pull. In non-magnetic metals like aluminum or gold, these tiny arrows point erratically in every direction. Billions of these disorganized magnetic poles are constantly fighting against each other within the material. Because they point every which way, the tiny directional forces cancel each other out, leaving the overall metal neutralized. Without internal structural organization, a material cannot project a magnetic field into the real world, regardless of its chemical makeup. Iron and steel, however, are rare physical exceptions that operate under a different set of internal rules. Instead of total chaos, their atoms naturally group into clusters called magnetic domains. Within these distinct boundaries, the electrons align their magnetic arrows in the exact same direction. These domains rest quietly inside the metal as independent pockets of unified magnetic force. When an external magnetic field approaches, it acts as a catalyst. The domains respond to the pull, smoothly rotating until every pocket matches the external force. Millions of microscopic magnets work in perfect sync, combining their poles into a single force snapping toward the magnet. This subatomic teamwork only happens when an external alignment pulls these domains into formation. Scaling back up to the human environment, this architecture explains how everyday objects behave. The aluminum soda can from earlier remains inert because its atoms are permanently stuck in chaotic disarray. They simply cannot organize themselves to respond to the magnet. The same rule applies to gold, or copper wiring in your walls. Their internal arrows remain totally disorganized, so they ignore an approaching magnet. A steel refrigerator door, however, is packed with those highly responsive magnetic domains, allowing it to capture and hold your kitchen magnets. The label of metal tells you almost nothing about how a material will react to a magnet. Ultimately, true magnetic attraction is simply a physical manifestation of strict internal atomic order and perfectly synchronized subatomic teamwork.